the actual roadmap that you can see for what we're going to go through. Like I said, we'll start with some of the basics. Then we're going to go into the current global disease situation. We'll talk about the clinical presentation for the disease, methods of disease detection, and finally, some control strategies that exist. So focusing in on the basics to start. Foot and mouth disease virus does belong to the Picornaviridae family. And if you break that word apart and look at it, the first part of that is pico, meaning small. RNA, it is an RNA virus. And then viridae, so small RNA virus, which is a perfectly accurate description for this virus. It's a member of the aphthovirus genus. And this is a non-enveloped, positive sense, single-stranded RNA virus. This is a really, really tiny, tiny virus. So you can see here, we really got about 8,500 bases, really tiny. If you think about something like African swine fever, you're looking at something closer to probably 190,000 bases. So foot and mouth disease truly is itty bitty tiny baby virus, but has a lot of diversity associated with it. So it's composed of 4 structural proteins, and that's VP1 through 4, and that VP means viral protein. And then we have 10 non-structural proteins. So when you guys look at these images on the right-hand side of the slide, you're going to see them pop up a few more times in the next few while we talk about the practical implications for understanding some of the virology. Foot and mouth disease virus has 7 different serotypes. This matters to you because this has a huge, huge effect on our ability to think when we think about disease control. Something that has a single serotype really lends itself to developing vaccines. Because what you want to understand about a serotype, if it's not something that you are too familiar with, you break down the word, right? Serotype, it comes down to the type of antibodies that are produced based on being infected with a certain strain of the virus. So a serotype, we've got 7 for FMD. So there's O, A, C. We have the SATs, those are the South African territories. And we have SAT1, SAT2, and SAT3. And lastly, we have the Asia serotype. Now, what this means is that if an animal is infected with an O serotype, but vaccinated with an A serotype vaccine, there's no protection that's offered against that O infection. They could potentially have protection against a serotype A, which would be the intent of using that. But something to keep in mind as we go through this. So from a vaccine standpoint, this is extremely challenging. It's also, I think, probably one of the most beautiful examples of a transboundary animal disease. We often call them foreign. Something to think about as a veterinarian is that foreign is relative, right, to where you are, where you live. So yes, these might be foreign to the United States, but if you're working internationally, working with other partners, other laboratories, other field staff, it may not be foreign to them. So it makes you sound a little silly if you call it a foreign animal disease in a country where it's endemic. It also begs the question of, we'll digress slightly, if you think about something like high path, right? That is a foreign animal disease for the United States, but we've been dealing with it pretty steadily for 2 years, which I'm sure has been a painful experience for most of you on this call. I know I'm tired of dealing with high path, but foot and mouth disease as a transboundary animal disease, those serotypes were named based on the geographic location where they were really first isolated and characterized. So you can see O is for, I don't speak French, but Ois in France, Allemand in Germany. C is also Germany, but something interesting about the serotype C is that we have not seen any outbreaks since 2004. So this specific serotype is actually under consideration for eradication by the global FMD community. Folks are getting together from countries all around the world to talk about what sort of data and evidence do we require to really be able to prove, right, to be able to call this serotype extinct. So that's kind of your fun fact for your next cocktail party. You could share that with somebody and, it makes it sound really cool. And then within those serotypes, again, when we talk about a diverse pathogen, we have more than 60 known topotypes or subtypes or strains, if you want to call them that, that exist within those 7 serotypes. So not all serotypes are equal. Some of them are more diverse than others, and that does, again, affect vaccine efficacy and the ability to develop vaccines for it. The example that I like to give is serotype A, which is notoriously challenging. The strains within that serotype are very distinct. You often need more vaccines, a variety of vaccines in serotype A to get appropriate coverage for what's circulating. You don't see as much cross protection within the serotype versus Asia 1, where there are really only a few vaccines out there and they provide excellent coverage across a variety of strains that may be circulating. All right, so coming back to our main question of why does virology matter? Well, it's really critical for diagnostics, right? We use aspects of the genome that we can manipulate and characterize to be able to test for the virus in different ways. One of the things that we'll run through today are the primary tests that we use that are used at Battle. We'll talk about some of the other ancillary tests that are available, but these are kind of your bread and butter. So you guys know PCR, right? We use it for everything. Sequencing, serology, and then we're going to talk about how those same aspects can play into vaccination capabilities and our DIVA capability. So this is where I'm going to pause and ask you guys, if you'll do me a favor and throw in the chat, does anybody know what DIVA stands for? And I'm going to try and set this up so I can see the chat. Maybe, yeah. All right.
Yeah, you can click on chat, yeah.
Yep. I've got a no, sorry. Differentiating infected and vaccinated animals. Jennifer Ray, you've got it. That's exactly what it means. So DIVA is going to come up again. We'll talk about that in more detail in a few slides. Thanks for participating. Okay, so looking at diagnostics, when we talk about PCR, we're looking at, and I've got the image of the genome again on the right-hand side, but it's zooming in on just that end, that 5 UTR region. And what that stands for is 5' untranslated region. There's also a 3' untranslated region on the other end of the genome. These untranslated regions are really important for transcription of the virus, so they regulate stability of the virus and provide that template for transcription. So important for PCR, where we're manipulating that process, right, to produce additional copies of the virus and prove that we did have some in that sample to begin with. 3D RNA polymerase is another aspect of this virus, right? Specifically, polymerase is necessary, again, for that transcription, that replication process. And then when we look at sequencing, this is most commonly used to identify the serotype. So when a sample comes into us, we're going to test it and we can say, yes, foot-and-mouth disease virus is present. The genome is there. It doesn't tell us which of those 7, or really, we hope functionally 6, right, active serotypes it might be. So we can use sequencing to target viral protein 1, VP1, as the target to tell us whether this is an O, an A, or a SAT, et cetera. Now, when we look at this, there's the whole genome again. I kind of expanded this one and blew it up for you a little bit. So you can see those structural proteins on the left-hand side. And then we have our non-structural proteins. So I want to talk about these because when we look at serology and running ELISAs, it's those non-structural proteins there in that now pink box that we're focusing on or that we're leveraging to give us this test. So when we run an ELISA, we're looking for antibodies, right? And what are 2 ways that you can get antibodies? You can get antibodies because you were infected with the virus or because potentially you were vaccinated against it. Now, in the United States, are we vaccinating for foot and mouth disease virus? Is that something that we routinely do? Throw it in the chat. Yes or no? No. Yes. Love to see all the no's. Thank God. Yeah, we don't vaccinate for this disease because it doesn't belong here, right? It is a foreign disease in the United States. We hold vaccine in a stockpile as, a just in case, right? But we are not vaccinating on a regular basis because it would change our trade status immediately. We're at the highest tier that we can get with being free of the disease and not vaccinating. So when you guys think about this, it's important to keep that in mind. In the United States, we're not vaccinating. So if we're seeing antibodies to FMD, we've got a bigger problem, right? The disease was here. They were exposed to it. That's bad news. In other countries where the virus is either endemic, right? So they're continually being re-exposed to probably a variety of serotypes. They may also be running vaccine campaigns. And they're probably not emergency quality vaccines, but right, you are going to see antibodies to those. So for us, most of our FMD ELISAs out there are reading the non-structural proteins. So you'll see that there's 2A, 2B, and 2C. There's also a 3A, 3B, and 3C. So a 3ABC ELISA is the one that FATO currently uses as their gold standard. So here in the US, apologies for the typo with only one parenthesis being there, non-structural proteins, right, for us mean disease was present. It was here, and that's bad. And so you've got some photos on the slide here showing you a really large ruptured vesicle up there on the gum line near the dental pad. And then in the interdigital space, you can see that white jagged tissue, that's epithelium that's been undermined. So it's obviously a vesicle that's ruptured. I can tell you those don't smell great. All right, so I need another level of participation in the chat. Why virology matters when we're thinking about vaccines and that DIVA capability. Let me ask you this. At its most basic level, how do vaccines work? Throw it in the chat. I'm not looking for a dissertation. I'm not looking for us all to be virologists or vaccinologists, but what is the purpose? Yes, Jessica, they stimulate an immune response. That was perfect. Yes, they train the body to respond. Well done, Liz. They activate the immune system. They cause an immune response. Yes, you guys are on it. Oh, we're getting fancy now, Nathan. They provide adaptive immunity. Yes, they do. So the whole purpose of it is we can stimulate the immune system to produce antibodies, right, to potentially protect them against the disease. Do vaccines typically provide sterile immunity? And what I mean by that is, do they prevent infection? Looking for a yes, no. No, exactly. Yes. God, you guys are great. Thank you. Correct. They do not prevent infection. What they are here to do, right, is to lessen the clinical disease. Now, that may mean that that animal never appears sick in the first place, right? It's such a low level of replication that you don't really appreciate the clinical picture. But when it comes to foot and mouth disease vaccines, you can see the images on the left hand of the slide, and I'm going to move my mouse over here. Can you guys see my mouse on the screen? And I'm moving it around over the capsid. Yes, perfect. So what we're focusing on in FMD is this capsid. And this here, this is an intact capsid, and that is kind of what we're looking for now with the vaccine bank. We're measuring an intact virion at 146S. We're not going to talk about, thanks, Jennifer, it works. I'm glad that you guys can see it. What we're really looking for here is that intact capsid. So 146S is kind of our standard for what we measure now, although empty capsids are also appropriate. They can still stimulate the immune response because these three proteins here, VP1, 2, and 3, are the antigenic component of this virus. So these guys, you can see they color code them. You'll take a protomer, they're going to fold themselves up to create a pentamer, right? These guys are going to fold themselves up to get us here, final form here as hopefully an intact capsid. We must have structural proteins. We must have intact capsids for our current vaccines to be effective. Without that antigenic component of the capsid, we don't get an immune response, meaning that vaccine's not really going to help us. So you guys were spot on because yes, vaccines stimulate an immune response. And for FMD specifically, it is the capsid that we need to get that. So we're going to break this down a little farther to the DIVA component. So we know, you guys know now, you're experts, structural proteins are good. We need those. So from a vaccine perspective, I want you to think of structural proteins as your sunshine and unicorns and rainbows. These are all of the good things that we want in a vaccine. We want them to stay intact. It's why we want to store them appropriately because we want to protect the good stuff. And then we're going to contrast that, right, with the rest of the genome, meaning those non-structural proteins. So what are they when we think about it in the context of a vaccine? They're trash. We don't want them in there. Okay, you can take Oscar the Grouch and think of him as non-structural proteins in a vaccine. They don't make the vaccine work better. They actually just confuse the picture for us. So in our modern FMD ELISAs, they're reading non-structural proteins. So it makes sense that for, in the US anyway, the vaccines that meet our criteria through the Center for Veterinary Biologics to be included in our stockpile, those non-structural proteins are filtered out of those vaccines, like those stockpiled by the USDA. So if you're asking yourself, well, antibodies are present, is it infection or is it vaccination? Your tool to kind of suss out that picture is to run an ELISA. And this is, again, specific to the US, a country that is free from the disease. That picture gets a little muddier, like I said, in endemic countries, but you guys live in the US. And if you're responding to an outbreak of FMD, right, it's likely to be here. So any questions on DIVA capability, vaccination, manipulating the genome to be able to run our fancy tests? Seeing, hearing, nothing. Good. It's time for a knowledge check on our virus basics. Okay, so can you guys see the poll quiz on the screen? I'm assuming yes. You can see the first question there is, how many serotypes of FMD exist? Thank you, Liz, for confirming. Go ahead and give that one an answer. The second question is, which of the which of the serotypes haven't been detected since 2004? You're welcome for that freebie. Sorry, Liz.
You can scroll down to see
That's
the
okay.
question
And then-
or enlarge the window.
Lastly, when detected through FMD ELISAs, which proteins usually signify that an animal has been infected and not vaccinated?
Okay, we're going to give everybody a little bit more time until we get more people answering the poll, and then we'll go ahead and we'll share the results. I don't see why I don't see share results on my screen.
So we'll give you guys a minute to go ahead and get those answered.
Wow, that's weird. I don't know. I don't see where it says share the results. I don't know why.
I think that comes up after you hit end poll.
Yeah, I didn't think so. I thought it was there. Maybe, hopefully. You know, it's like we did this in March. What is it, August? Okay, I think I
Zoom-
practiced
Zoom
a
updates
million
on a
times
regular
on Friday.
basis.
Oh, I know. Now they have surveys and all this stuff. It drives me crazy. It's okay. All right, so let's see. We have 47 of 49 participated. I'm going to go ahead and I'm going to end the poll. And there we go. Share results. Look at that. Look at question number 1.
I mean, are you guys good or what? And also, I shouted out the answer. But you got it, because if you missed it after that, I'd have more questions. All right, so which serotype? So, okay, first of all, yes, guys, there are 7 serotypes of FMD. Great job, everyone. Question 2, which serotype hasn't been detected since 2004? That is serotype C. It looks like the majority of you guys, 88%, did get that. And then, when detected through ELISAs, which proteins signify that an animal has been infected, not vaccinated? That may have been a bit tricky, but again, the majority of you guys, almost 80%, got that. It is non-structural proteins. NSPs are the trash. That is Oscar the Grouch. We don't want those in our vaccines, but if you detect them on an ELISA, it does mean that that animal was infected. All right, well done. And then I do see in the chat, we have a question. Do vaccinated animals shed and transmit the same or less virus than unvaccinated animals? Kaylee, spot on. Vaccinated animals shed less virus. They do still shed virus. So that's important when we're thinking about movement and risk and things like that, but they do shed less virus than an animal that is non-vaccinated. All right, guys, so we're rolling forward. Let's talk about, where is FMD today? So our first slide here, you'll notice there are 7 pools. Conveniently, there are 7 serotypes. That's not the match. Those don't match. There's no relation, but it just works out that way. We have 7 pools globally. The way that the FMD community talks about viral circulation is through these pools. This is where we've typically seen that geographically certain strains or certain serotypes kind of routinely circulate on a low level all the time. So we're really accustomed to seeing, right, cases pop up there tied to those serotypes. So if you look at this, you can see pool 1 in red is Southeast Asia, Central and East Asia, and we typically see serotypes OA into Asia 1. That's similar for pool 2, which is kind of that orange tan color. That's South Asia, same kind of serotypes that tend to predominate there. Pool 3 is in yellow. This is West Eurasia and the Near East. Again, same 3. And for your awareness, guys, serotype O is the most prevalent serotype globally. We see the most cases with it. It's an incredibly diverse serotype. So it's not unusual to see O in many of these polls, if not all of them. A is kind of our close second, but we'll talk about some interesting things that have happened in the past few years with this. So moving on, pool 4 is in greenish, yeah, I guess that's a light green. That's North and Eastern Africa. We're starting to see SAT1 and SAT2 circulating there. Pool 5 is in that grayish blue color. That's West and Central Africa. Again, similar, OA, SAT1 and SAT2. Pool 6, Southern Africa, the serotype that was named after the South African territories. It makes sense that all of the SATs would be found there. You can see that they have slowly expanded north because we're seeing them in West Central and North and Eastern Africa. And then lastly, we have South America. So you can see pool 7 in purple has been tied to serotypes O and A. Now, if we look at a map from WOA, where has FMD been in the past 10 years? So we're looking at 2013 through 20, and looking at this map, and I don't love that WOA likes to use green and red, but you'll see there's a lot of red. And what part of the world do you commonly see that? I mean, if you look at our side of the planet, very little red, but I hope that you can appreciate down here in South America, if I can figure out how to get my mouse on the screen, down here, right? We're seeing some small clusters of cases within the past 10 years, but by and large, right, those other 6 circulating pools, right, have the large majority of all of the cases. All right, trying to get my mouse back over here. My God, okay. Now, here's a map of what the world actually looks like. So I'll go back really quickly, look at this. This is what we're used to looking at. We're used to looking at those lines. Well, they're real, right? They have implications. Crossing borders comes with consequences. You need to, abide by the laws of a country that you're crossing into. But in reality, you can see those lines aren't there. So when you think about disease spread, we're going to talk about these regions. We're going to talk about these countries. This is what that virus sees. They don't see borders. They don't respect borders. They don't respect cultural differences, right? They're going to move indiscriminately when they have the opportunity. So we focus a lot on the countries and those detections and things like that. But, right, that is something that we as a species have built for ourselves and drawn lines. We certainly have natural borders. You can see there's mountain ranges, there's bodies of water and things. But keep this in mind when we talk about transboundary animal diseases this week. And then let's look at some recent outbreaks. So this is within, I believe, the past 6 months. So again, we're back to looking at, we've got all of our nice borders and all of our countries defined. But you can see we've got some cases kind of popping up in a variety of regions. We've got some in the Middle East, North Africa, down in South Africa, and those SATs are circulating pretty routinely. You guys also have to keep in mind, right, there's Kruger National Park. So this virus circulates in wildlife. So it makes it much, much harder to get rid of. The blue lines, Jessica, yeah. So when you guys see the blue lines, don't stress too much about those. This is kind of WOA's way of incorporating that those are under political discussion, let's say, those territories. All right. So those are areas where there's, whether it's recognized politically and formally. So those are, you don't need to stress about the blue. They're just marking those geographic boundaries that may be under consideration for change. Bonnie, how recent did I say that these were? This is probably from January through June of this year. So the last slide was the past 10 years, 2013 through 2023. This is the first, and even, I want to say probably the first 6 months of 2024.
Amy, there's another question. It says, I'm assuming that even in pools with the same serotypes, they have somewhat distinct variations in the strains.
Yes. Lauren, sorry I missed your question. Yes, you are correct. So the serotypes may be circulating. So we saw O and A that was in South America. You're correct. There are distinct strains within those serotypes that are specific to South America that we have not actually seen in other areas around the world up until recently. So I'm going to show you a fun case example. But yes, so in general, those geographic pools there are strain specifics within those serotypes in each one, even though you'll see the same serotype in many of these pools. Great question, thank you. All right, guys, this slide was meant to really showcase, so this is from April through June of 2023. Again, I'm highlighting, these are things in terms of FMD transmission that really took a lot of us by surprise. We could see that there were some really interesting changes happening, and we had just kind of come out of this period during COVID, where for almost 2 years, we had very little information about what was circulating. We didn't have the same level of sample submissions, and this is globally. I'm not talking specific to the US. I'm talking the World Reference Lab. Pirbright wasn't receiving samples in the same way that they normally did. Now, on one hand, we could say, okay, most countries are experiencing lockdowns of some kind, right? Some level of public health restrictions. So we suspect that people and animals are moving less frequently than they were right before we entered into a pandemic. So I think there was that, but it was really almost this black box where we didn't have good visibility. And as we came out of that kind of toward the end of 2022, we started to see an uptick in submissions again. I'm happy to say now, right, we're kind of operating at more of a normal level. But in 2023, so you've got the 7 pools on here. And then if you guys can appreciate each one of these dots where there's a red ring around the black dot, these were novel outbreaks for us. So we started down here with SAT2. We started to see kind of the emergence of a strain within the SAT2 serotype that hadn't really been recorded all that frequently. And all of a sudden, we're starting to see a number of outbreaks with this kind of quiet strain. So some of these other ones you'll see if you come up north, what was interesting here is you'll notice this outbreak here in Tunisia and Algeria and Libya. It's not in a pool, it's outside of it. So we kind of saw the spillover of an O East Asia 3 strain. And then we looked, and in pool 3, we started to see, oh my, okay, now we've got a SAT2 in Bahrain, Iraq, Jordan, Oman, and Turkey. Now remember, SATs are South African like territories. That's a serotype that is normally present down here in the southern countries in Africa. And we sometimes see spillover into some of the other pools within Africa, but now we've seen a jump off of the continent. And that got everybody's attention. And this has been a very, very large outbreak for them. Turkey's mounted a very large vaccination campaign trying to get this under control. And then we saw Palestine, and this strain, this Middle East, Southeast Asia, Pan-Asia 2 strain, it's really being classified as a pandemic strain. It's causing outbreaks everywhere for us. So you can see down here in the United Arab Emirates, down here, similar strain from pool 2 that was being, back it up. We're starting to see this creep up, and it's continued to creep up in a variety of places. So that's strain specific to Lauren's question, right? You can see we've got a 2018 topotype here, and then down here, this India 2001E. Affected Indonesia, again, outside of a standard circulating pool. All of the islands have been affected. We also saw that same strain, that India 2001E, hit South Korea. So some interesting things happening, and we're going to look a little bit closer at the SAT2 outbreaks in the Middle East. So to orient you on this map, there's a lot of red that you'll see there. That is that ties into the distribution of small ruminants. So the darker the red, the more small ruminants there are in that region. And then you can see all of these little triangles kind of peppered throughout here. So those triangles in green represent a SAT2 serotype that was detected. Yellow is an O serotype, and then those in blue were not actually typed. So the samples were sent in. They didn't have a sufficient sample to be able to sequence it and type it, or the quality of the sample. But please note that the majority of these are green. So when I said this was a very, very large outbreak of SAT2, you can see, I mean, crossing borders, right? That virus doesn't see lines. So this was a pretty rapid progression. In 2021, we had a detection in Egypt, the SAT2 serotype. By December of 2022, it had made its way into Jordan, right? So it kind of crossed over. By February in 2023, it hit Iraq and Syria. By March, it was in Turkey. And by July, it hit Oman, so all the way down here. And then this year in 2024, we've continued to see, so those are ongoing outbreaks in Northern and East Africa, in the Middle East, and then now pulling in Bahrain. So Yes, no question for you guys here. Has anybody seen any of this in the news? Right? We hear about COVID, we hear about HiPath, we hear about ASF. No, exactly. Don't sleep on FMD. It's moving, it's making moves, it's doing interesting things, it's keeping everybody on their toes. But it's interesting to me that we don't see the same level of coverage in the media, which argue sometimes is a good thing, but also, right, from an awareness standpoint, maybe isn't that helpful. All right, time for another knowledge check. Let's talk about the current global FMD distribution. You guys should have a poll that just popped up. This first one, I don't know that we talked about it specifically. I'm trying to think back, but when was the last time FMD was in the United States? And your options are the 1850s, the 1920s, the 1980s, or FMD has never been in the US. Second question is, which serotypes have been causing unusual outbreaks in the past 3 to 4 years? So your options are SAT serotypes and the O's, serotype A only, serotype C and A, or serotype FAD. And then your third question is, how are routinely circulating strains of FMD identified and organized geographically? What do they call those? Are they called clusters? Are they locally given names? Are they regions or are they pools?
Okay, I'm going to go ahead and end the poll.
Got faith in you guys. Let's see how you did. Okay, scrolling up to question 1. So well done, guys, because this was not, I don't believe I said it out loud. It was on a slide, if you caught it, but the 1920s is correct. So 1929 was the last detected outbreak of FMD in the US. And let's hope that we can hit, 100 years or more, keeping it out, and we're getting close. So which serotypes have been causing unusual outbreaks in the past 3 to 4 years? Yes, well done, guys. 98% serotypes SAT and O. So kind of some of those that we flew through pretty quickly, but they've been doing some really interesting things. And then how are routinely circulating strains of FMD identified? You guys have got it at almost 90%. They are pools. They are based on regions, which is tricky, but they are called pools. Thank you, guys. Let's keep moving on. We're going to talk about the clinical presentation. So our host strains for FMD, we've talked about how the virus itself has a lot of pathogen diversity. Well, unfortunately for us, the host range is also very diverse. So all cloven-hooved animals, which means, right, like 2 hooves, if you're doing like the Spock kind of thing, and elephants. But when all is said and done, more than 70 different species are susceptible to foot and mouth disease virus. That's terrifying from a control perspective, right? That's wildlife in addition to our domestic species. But let's focus in on our domestic livestock hosts. So for us in the USDA, who are we looking at most closely, right? We have our sheep and goats. These guys are considered our maintenance hosts. Then we have pigs, they are amplifiers. And cattle are considered our indicator species. So let's look at that in a little more detail. So transmission of the virus in general, just like most viruses, direct contact. If you breathe it in or you eat it, that's a great way to get infected with really anything. That's not even specific to viruses. You guys know this. Movement of infected animals, right? And especially some of them, right? So when we talk about amplifiers, these guys shed a ton of virus. So movement of animals in that period before they look clinically ill, right? A big threat to us. And then, just like most other viruses, indirect contact also offers a viable mode for transmission. So these are things like fomites, contaminated forage, contaminated milk and meat, semen, so AI is a great way to spread this virus, and garbage. But when you look at these animals, any bodily fluid, anything that's being excreted, put out from the body, is going to hold virus. Saliva, urine, feces, milk, all of it. They do shed virus before they're clinically, obviously ill. And then, as we discussed earlier, vaccinated animals will also shed virus. If we look at cattle specifically, because just like the virus, right, not all species and strains are the same. Cattle in general are considered highly susceptible, to aerosol transmission. This is due to the sensitivity of the nasopharyngeal mucosa This is also the preferred site of viral replication in these guys. So back in that oropharynx. Again, this is shed in the milk, feces, urine, semen, saliva, all of it. And they are shedding the most virus, right, at the peak of their clinical signs. Part of this is because a vesicle is an excellent sample for you to take in the field. There is so much virus, right, per mil of vesicular fluid. So you can imagine at the peak of this virus, when they have the most vesicles developed, theory, right, hypersalivation, they are just pouring virus out into the environment. Swine are a little different. They're considered more susceptible to ingesting the virus, so eating it. Although, you know how pigs are, right? They root around, so argue with me. Did they breathe it in? Did they eat it? Right? Either way, right, through the mouth and the nose is our primary source for infection. They do have a shorter incubation period than our other species. And part of this is because they are amplifiers of the virus. So what this means is their immune systems, for whatever reason, FMD gets introduced and these guys go nuts. There's so much viral replication. They will shed an absolute ton of virus into the environment. So replicating more, shedding more also tends to mean, right, their clinical disease is often very severe. FMD, while rarely fatal, is a really unpleasant disease to see in swine specifically. And it makes sense when you look at the biology that's happening here. And then our sheep and goats, these are our maintenance hosts. So they are incredibly stoic. There's not a really obvious clinical picture here. The infection is very, very subtle in these guys. From a research perspective, right, say they're more susceptible to infection through the aerosol route. Because they are smaller, there's a lower respiratory volume. It does decrease their mode of transmission, right, and breathing it back out. But you can see a lot of variety or variable transmission rates between herds and between strains and breeds. But these guys are going to be problematic. They're not going to look obviously sick. In some cases, unless you're going to get in and really look in the mouth or look between all of their feet, you may miss it. When you guys go out to Plum for the FAD school, you're going to see these guys in a room. And I mean, it is striking to see the difference. There's a family room. So there'll be pigs, there'll be cattle, and there'll be sheep in there. And the difference between them is really, really fascinating to see. Now, let's talk about carrier states. When we think about transmission and being infected, a carrier is really defined as an animal from whom you can detect virus from the oropharyngeal region 28 days after infection. So this applies to cattle and sheep and goats only, and African buffalo. We don't have a lot of those in the US. But you could see, again, when you think about South Africa and those territories where the virus is circulating, right, they do have African buffalo. They are true carriers. These guys can remain infected. You can find, right, viable virus up to 5 years after they're infected. Now, for most of our domestic livestock species, so cattle, you can see carriers. They've been able to detect it up to 3.5 years after infection. Sheep up to 9 months, and goats only up to about 4 months after infection. And in terms of the incidence, greater than or equal to 50% of cattle may go on to become carriers, which is not a great stat for us, but this does apply to both vaccinates and infected animals. Pigs are not carrier animals. So that is a win for us, right? The amplifier species does not go on to become a carrier. We've been able to prove that scientifically. That's great. So keep that in mind. Carriers, we're talking about cattle, sheep, and goats, never swine. And those general clinical signs. This is not a very creative disease. We called it foot and mouth disease. Shockingly enough, that's where we see the majority of clinical disease. It's in the mouth and on the feet. The virus loves stratified squamous epithelium. So think about your mucosal surfaces. So in the mouth, right, between the feet, the teats. So high morbidity, meaning a lot of animals are going to get infected. It's very easily transmissible. Mortality is very low for FMD. We typically see less than 1% mortality. And when we do see it, it's often in younger animals. So otherwise, like most viral infections, right, fever, they may go off feed. You may see, right, they're depressed. They may be lame. You see hypersalivation. That's most common in cattle. You can start to notice other signs, maybe early in the disease process. So blanching of the coronary bands is a nice sign that you've probably got some vesicles that are starting to form there. And then your obvious vesicles or erosions, if they're already torn, right? So you may catch it later in the disease. Around the coronary bands, that interdigital space, the tongue, snout, oral mucous membranes, and teats, primarily in cattle. Gross lesions, again, vesicles. So this is not a disease where you're going to get a lot on necropsy. It's really largely an external disease, but you can see some signs. So we do see erosions on the rumen pillars on necropsy. We actually had really excellent lesions in the last course. It's very cool to see because you don't always necessarily get those. And then when we do see fatalities due to foot and mouth disease, as I said, it's usually in younger animals. And what we're seeing is that the virus, for whatever reason, has the opportunity to hit the heart. So myocardial damage and necrosis of that muscle, right? Necrosing heart muscle means it's not able to beat, kind of overwhelms these guys and they die. And that's what we call a tiger heart or tiger striping. And I'll have some photos of that. But at its heart, guys, it is a vesicular disease. So vesicles are your really like your primary clinical sign. So here's some images for you. You can see hypersalivation in this cow over here on the left. And you've got cow hoof here, and you can hopefully appreciate a little bit of blanching here at the interdigital space. So that white tissue is evidence that that layer of epithelium, there's fluid development underneath it. It's been undermined, it's lifted, it's lost its blood supply, giving it that pale white color. Up here on the snout, you can appreciate by the yellow arrows, there are a couple of lesions here, some of which are quite subtle. So just kind of something to think about. And then down here, you can see we've got some teat lesions. Let's go ahead and skip forward to aging lesions. This is something that can help you guys out. If you ever go respond to a vesicular case in the field and you are seeing vesicles, it's really great for you to give us some context for how old that lesion is. So if you look at these images up here on the top, these are examples of early vesicular development. So this one here, it's undermined. You can tell there's probably some fluid underneath it. It's difficult to get fluid out of a vesicle like this, especially if you're by yourself on the farm. Be safe, first and foremost. What you can do is also take that epithelial tissue, right? You can kind of rupture it, take the flap, and send that to us. So you've got some other examples here. This one is quite small, right? That wouldn't necessarily strike me as a vesicle. Initially, it almost looks more like a papule. But then you can kind of see there's some saliva over this one, but you've probably got a vesicle right underneath this. If we could be nice to clear it off, but you can see the white tissue at least. And then here, right, 3 to maybe 4 unruptured vesicles on the tongue. When we go down to the later ones, right, this is what you're probably likely to see is that we've already got some ruptured vesicles. Again, you can take some of that epithelial tissue or take a swab, kind of roll it around on that. Another nice ruptured vesicle. You've got a little bit of granulation tissue coming into that one. Tells you healing has already started. And same with this tongue. So this is obvious, right? I think this is going to get your attention if you're out in the field. But these are already starting to heal. So you can see, like I said, that maybe some fibrin on top, but definitely some granulation tissue there. Now let's look at the feet. So up here again, these early lesions, right? This might be tough to appreciate. Right? If you're out on a farm looking at this, and they may or may not be lame. Now, once they rupture, this tends to be right a bit more obvious. This one, again, a little more subtle. You can see somebody's using forceps or metal, tool there to kind of pull that back to show you. But this blanching is kind of one of your key indicators that you may have early vesicles developing. All right, now we're looking at swine. So you can see these are highlighted by white circles for the most part. Very, very small vesicle on the snout. If any of you have seen Seneca Valley virus out in the wild, it looks almost identical, right, to FMD. That's why we're always sending those samples in. But vesicle development on the snout in swine is very common. So you could see, again, this vesicle here, blanching along the coronary bands, a little more subtle. But when you start to look at the bottom of the foot, right, there's much more blanching. You can see it seems like it's almost got a pillow-like kind of feel to it. It's, there's fluid underneath that for sure. And you can see them. We've got ruptured vesicles here on the dew claws. So this vesicle that's now ruptured on the snout of this swine looks like an erosion. If you came in, pigs are scraped up all the time. So, right, can be subtle. Now, odds are it's not going to be the only pig that's affected in that herd. So, you know, it's not like you're going to show up and necessarily see a one-off, but just so you can appreciate they can be quite subtle. All right, older blanching along this. You didn't get really a blown out vesicle, but I hope you can appreciate that it probably was, right? Quite swollen. You had fluid underneath it. If it didn't rupture, it's now kind of on a healing process. And then over here, this is what, say, I'm pretty accustomed to seeing in swine. They tend to be very dramatic lesions. We often see this in the FAD school where you start to see sloughing. These have torn. Some of these guys will even actually slough their keratin casings. All right, another example for swine. So a subtle lesion on the tongue, another subtle lesion on the lip there. But let's go ahead and take a look at our sheep and goats. So again, looking right into the mouth for this one, and here you go, get a lesion. Pretty subtle. You'll notice there's no saliva, there's no spit bubbled. These guys are really, really subtle. This is a beautiful example of a ruptured vesicle in the interdigital space. You can't bank on it always being that obvious. As maintenance hosts, they are, right, the disease is quite insidious in these guys, very subtle clinical signs. Now, during necropsy, we talked about that tiger striping. So hopefully you can appreciate, right, here we've got a heart, but these white spots of tissue here, right, that's dead muscle, that's necrosis. And then these are some of the lesions talked to you about on the rumen pillars. So they were vesicles, they've ruptured. So usually when you see them on necropsy, right, there's a lot of movement in the stomach and the rumen. So you're probably going to appreciate erosions, not necessarily intact vessels. Now, differential diagnoses. You guys are going to be pros because I'm going to talk to you about the endemic rollouts tomorrow morning. But you can kind of see here, we've got a variety of diseases, right, that also present in a vesicular or vesicular-like disease presentation. So vesicular stomatitis, malignant catarrhal fever, blue tongue, EHD, Seneca virus, we already talked about that. Swine vesicular disease, vesicular exanthema of swine, your parapox viruses, PPR. You guys are going to hear about PPR later this week. Mucosal, IBR, BVD, sheep and goat pox. And then outside of those infectious causes, right, don't forget to keep in mind any trauma or potential toxicity. So that's all we're going to go through with this list today because you're going to get it in detail tomorrow. And it is time for another knowledge check. All right, first question. How many species of animals are susceptible to FMD? Second question is what tissues or fluids is foot and mouth disease virus shed into? And then lastly, which of the following species sheds the most FMD?
And Jamie, once we launch, we end the poll and share the results. There is a question in the chat, so we'll address that too.
Is the spread risk via AI through frozen and or fresh semen? Yeah, so with virus being present in the semen, I don't have specifics for you. So fresh semen, certainly, without a doubt. Frozen, I would have to do some digging to know how well the virus would be able to hold up. So viral stability, once it's frozen, a lot of times can break apart that capsid, cause damage to it, which might, right, reduce the infective nature of that virus. But Taryn, that's a really good question. I'm going to have to make a note and look up and see if I can't get you some more of like a specific risk profile on those. Yeah, thank you.
All right, we're going to end the poll and share the results.
How'd you do? Oh my God, you guys are crushing it. Look at this. Yes, greater than 70 species are susceptible, and 98% of you got it. Love to see it. Question 2, you guys got it. All of the above. Shed in milk, feces, saliva, and semen. And lastly, which of the following species sheds the most FMDV? A little over 90% of you got it. It is swine. Nicely done. Really proud of this group. All right, I see another question here from Jeffrey. It seems the distribution maps favor the more arid climates around the world. Is this due to the distribution of small cloven-hoofed animals or climate factors? Ooh, spectacular question. Jeffrey, I don't actually know. But you're right. You can see areas where I think that smallholder animal production is a big component of it because it is more subtle in our small ruminants. I also think, when you look at a lot of these places that are consistently affected by it, and you think about their national animal health system and their capability to respond, the ability to get out there for testing, to really do solid surveillance, the resources, right? Just in, not all of them, but in a lot of them, the same level of resources just aren't going to be there. But I think it's a great question. And I don't have a great answer for you. Okay. All right, guys, we're getting there. We're in the home stretch. I promise there's not much more. Disease detection. Let's talk about those tests that Battle's running. You guys are familiar with most of these assays. So PCR, the question that we're asking, is viral material present, right? Are pieces and parts of the genome there? It doesn't tell us whether or not it's viable virus, but it does tell us that the virus, right, is present. When we look at our antigen ELISAs, this is answering the question of, is the virus present? And if it is, which serotype? Then we have our antibody ELISAs that we talked about earlier in this presentation, which is really asking, was there an exposure to FMD? And by this, we mean, was there an exposure to, right, wild type FMD, not to a vaccine? We also have agar gel immunodiffusion. This is again asking that similar question. Was there exposure to the virus at some point? Virus neutralization is the same. Was there exposure to it? But virus neutralization will also be able to tell us which serotype they were exposed to. Then we have virus isolation. So when you think about bacteria, right, we culture bacteria, but we isolate viruses. So this is the act of actually trying to grow or replicate the virus to see if it's viable. So is that virus alive, right, and able to replicate? And then sequencing, we're asking which serotype is present. And then you've got the testing timelines over there on the side. But let's look at our samples. So the caveat here for all of diagnostic services is please always label your samples. Label them, be specific. The lab loves that help. All right, but vesicular flap, you guys are going to collect this and you're going to put it in TB media. We will also take vesicular fluid. Again, really great sample. If you can get the fluid to put in there, great, put it in TB media, but a swab is also an excellent sample for this. So again, hard to get fluid out of a vesicle, but you can take your swab, swirl it around in there, right? Swish it around in your media, and then please take that swab out. Don't leave it in the tube. We do not use swabs with wooden handles. Any bacteria, right? That's not a sterile sample that you're collecting. If you collect it with a cotton swab that has a wooden shaft, we often end up seeing bacterial growth, right? Bacteria take advantage of that media and they can overpower any virus that might be in that sample. The other bummer for cotton swabs with wooden handles is that viruses really love cotton swabs. They're very sticky. The virus will hang on to that cotton swab rather than being left in the media, which is what we want for those guys to be able to test it in the lab. So this is where we look for those polyester swabs that have the plastic shaft. So you get your swab, swirl it around in the media, and then go ahead and take it out and close your tube. We would like you to collect a red top tube. So label it clearly, please cap it well. Leaky samples are terrible for everyone, and then they contaminate everything else that they were packaged with. Purple top tubes are great, and this is not necessary for FMD itself, but for those other differentials. So epizootic hemorrhagic disease, blue tongue, malignant catarrhal fever, and then probang samples. So probang samples, if you've never done one, right, is that tiny little metal cup you're going to stick in, kind of scrape the oral pharynx and get some of that fluid and cells, right, from the back of the throat. We don't collect these very commonly, but if you guys were paying attention earlier when we talked about animal status, when do you think that it would be most useful to collect a probang sample? Throw it in the chat. Would this be, yeah, suspect carriers. Nicely done, Nina. Nicely done, Jeffrey. Yes, Catherine. Awesome, guys. Probangs are most useful if we're looking for carrier animals. So this is a sample for later. later in the disease, right? This is not something that you should go out and collect when you're out there for an initial investigation. Nicely done, guys. But before you go out for any investigation, this is our plug for, right, your FAD investigation manual. Always, always, always give this a review before you head out into the field, right? Just to make sure that you've got the right supplies, that you're prepared to collect the right samples, so that when you get out there, if it's not necessarily an ideal situation, and it never is, right? You've got backups and you're prepared with all of your supplies. Now, when we get those samples, let's talk a bit about what FADL's going to do with them. I say we, guys, I did work at FADL for a long time. I don't anymore, and I can't get rid of the royal we. But tissues, swabs, and vesicular fluid, when you send us any of those samples, those guys are going straight to PCR, and they're also going forward for virus isolation. So we're looking to understand, is the virus present and is it viable? Those red top tubes, that's where we're going to run our ELISA. So that 3ABC ELISA, we're looking for those non-structural proteins that will tell us, were they exposed, right? And it was a true infection because we're not vaccinating in the United States. We will also send it forward for the AGID, or the agar gel immunodiffusion test. It does have a more flexible incubation period, and this lets us do testing over the weekend if we need to. And then highly suspect or high priority cases are likely also going to be sent over for antigen ELISA to help us with that serotype determination. They're definitely going to go to virus neutralization and sequencing. We have a few others, but those are the big ones. And with that, it is time for another knowledge check. Okay, first question, which of these is not a sample type for FMD virus detection? Whole blood, vesicular fluid, a lesion swab, and a vesicular tissue flap. Now, this one might be a little tricky for you guys, so I want you to focus on those that would be the priority samples. They're going to get you the most bang for your buck. Second question is, what is the primary test for identifying FMD virus? ELISA, virus neutralization, PCR, or agar gel immunodiffusion. And lastly, if a 3ABC ELISA test is positive, what does that mean? The animal is actively infected with the virus. The animal was vaccinated for FMD. The animal was previously exposed to foot and mouth disease virus. Or D, virus is present in the environment.
And here's your results.
All right, let's see how you guys did. Yes, well done. So which is not a sample type for FMD? Whole blood. About 80% of you got it, so I want to talk about this for a minute. So the other three on here, vesicular fluid, that epithelial or that lesion flap, vesicular tissue flap, or lesion swab or the flap are great samples. It's a ton of virus in those. You will probably collect whole blood and a red top, but for detection of this virus, that viremic period is very, very short. Very short. So this is mostly an external disease, but a lot of these samples, like whole blood, are valuable for testing for other differentials, kind of along with that purple top. So sorry if that was a bit confusing, but glad the majority of you guys got that one. Primary test for identifying FMD virus. PCR is our primary test, right? This is our bread and butter. You know, we're going to take that lesion, that swab sample, the fluid, the flap, you name it. We're going to throw it on PCR first. ELISA, I see a number of folks picked it, and we've talked a lot about ELISA. ELISAs are good, right? We're looking, right, kind of retroactively. Were they exposed to it? And it's important to us to differentiate, right? Was it a vaccinated animal or was it an infected animal? But that's in the past. We've already missed the active infection. So number 3, woo! Okay, number 3 threw us for a loop, huh? All right, so if a 3ABC test, ELISA test is positive, what does it mean? Does not mean that they're actively infected, right? We're looking at antibodies with the ELISA. So we're looking at, were they exposed to it? The animal was vaccinated for FMD. No, if the ELISA test is positive, it means that non-structural proteins were identified, which are filtered out of our vaccine. So that would not be a vaccinated animal. And the answer was C, they were previously exposed to FMD, although to your credit, whoever said D, yeah, there's probably virus present in the environment somewhere if an animal was infected. But this test would not be used to test that sample. Wouldn't be appropriate for environmental sampling. All right, good job, guys. I know some of these are tough. We're on our last section. This is control strategies. All right, economic importance of FMD. You guys are going to hear a lot about this for a lot of transboundary animal diseases. Don't let it distance you from the reality of this. We talk about economics, we talk about it on a national scale, but that's made up of individual people and producers and farms, right, who are affected by it. So economics matter, right, for the folks that we're here to serve. FMD does rank among one of the most economically devastating animal diseases in the world. Direct losses, right, are really what's taken that chunk, because again, the disease is rarely fatal. So it's a disease of lost production. We're losing milk production, loss of cart power, right? Growth is stunted. Abortion in our pregnant animals, death in calves and piglets and lambs. Well, it's not common, right? We do typically see it in the younger animals. And then we have our indirect losses. So those are things like the disruption of trade of those animals and their products. So let's look at it in a little more detail. I've got some examples for you. So one of those is Taiwan in 1997. FMD was detected. This broke a 68-year-long streak of being free from FMD. They lost 38% of their swine population. And the interesting thing about this outbreak was that this was a serotype O, I believe, that only affected swine. It's a weird, I don't know, I find that very interesting for this virus, that it didn't affect cattle in the region. It's only swine. So this actually delayed the identification of it as foot and mouth disease. They were looking at swine-specific diseases, and it definitely meant, right, that this disease had the chance to spread farther. They didn't have the control, the detection, and then the control mechanisms in place quickly. Their estimated losses were at about $6 billion US, in addition to obviously losing that disease-free status. So that affects their trade markets. So the loss of their port export market was then estimated at about $15 billion US in 97. We also had an outbreak in the United Kingdom in 2001. This broke a 24-year long streak of freedom from FMD. This actually spread to Ireland, France, and the Netherlands. The outbreak was estimated at about $29 billion US, and they were able to get this under control in 11 months. So in less than a year, $29 billion, but multiple species were affected. This was identified in sheep, cattle, and swine. And then just it's something for everybody to be aware of with most of these diseases, we always, you kind of keep in the back of your mind an intentional introduction. So agroterrorism or bioterrorism, somebody who wanted to disrupt our economy, right? We have a $100 billion per year industry in our animal agriculture. It certainly makes for a nice target for somebody who wanted to do a lot of damage. And this isn't something that we look at and say, oh, it could happen. Intelligence reports that were identified in a multitude of countries who wanted to target the US specifically listed FMD as an agent that they were in a list that they were evaluating to use for an intentional introduction. All right, so what happens if FMD is detected in the United States? Well, the Secretary of Agriculture is likely going to declare a state of emergency or an extraordinary emergency in this instance. And USDA is probably going to institute an immediate 72-hour movement standstill. This first 72 hours is our opportunity to get a grip on, right, where was it detected and how far has it moved since then, right, so that we can institute control areas and things appropriately without allowing a lot of movement to further confuse the picture. In endemic countries, so I see Catherine has a question in the chat, do other countries include non-structural proteins in their vaccines? Girl, I'm about to answer your question right now. It's almost like you knew. So endemic countries often use multivalent whole virus inactivated vaccines, and that's fine. So they'll include multiple strains in it. When they're doing this, they're typically vaccinating once every 6 months. That's the required cycle. But you'll notice it says no DIVA. There's no ability to differentiate between infected and vaccinated animals because Catherine nailed it. These are not necessarily high quality vaccines where they're filtering those non-structural proteins out of it. So they're leaving that whole virus intact, no filtration. It will confuse the picture over time. The other difference to keep in mind, the vaccines that we stockpile are emergency quality vaccines. They're higher potency, very, very, very high quality, that are highly, if not ultra filtered. Countries who are dealing with this all the time are generally not using those same products. They're using a standard vaccine And it often does have non-structural proteins present in it. So yes, great question. But it means, right, it confuses their ability to differentiate between animals that were infected and animals that were vaccinated. All right, for FMDV-free countries, right, we are relying on things like movement control, stamping out, right, carcass disposal, sanitation, right, decontamination, and biosecurity. Biosecurity for everywhere, all the time, for all of the things. Vaccination is a tool that we have if we were to have an outbreak and it were to exceed our capability to stamp out. And then reporting is a big component of this. And again, reporting is based on transparency. So when you look at those maps based on reporting, take it with a grain of salt. It's always an underrepresentation of what is actually circulating at any time. Now let's talk about stamping out versus vaccination. So stamping out only gets you disease freedom status quicker, right? But it's very expensive, very costly. This isn't a disease that often kills the animals. So that's a lot of protein loss that we're losing, or milk loss, that, things that aren't entering supply any longer. Vaccination only would be rare. This would have to be an extremely large outbreak for us to be only vaccinating and no longer stamping out. So economically, this is more manageable for us, but this is not an outbreak that we're likely to contain anytime soon if that's the option that we've gone with. So what we're most likely to see in an outbreak is probably vaccination used in addition, right, to the standard stamping out practices. And in an article from 2017, they found that this kind of tandem approach significantly reduced the outbreak size. So Sanson et al., 2017, anybody who's interested in reading that. And the other important thing to remember, guys, vaccination is not a day one response tool, right? Day one, we've got our detection, we're shutting everything down for at least 72 hours to get a grip, right? To figure out where is it gone, what are we gonna do, what strategy is most appropriate. Vaccination is something that we look at typically a little later in the response. Prime example, there are vaccines out there for highly pathogenic avian influenza. We have not used them yet, right? We have stuck to the stamping out response. So just a tidbit to leave with you. And our last knowledge check on control strategies. All right, what is the estimated cost for the US to recover from an outbreak of FMD? So we talked about on one slide what kind of a target our animal agriculture industry represents to somebody. 100 million, 100 billion, or 100 trillion. Question 2 is, what are possible control measures in FMD-free countries? So free countries, we've got animal movement, stamping out, sanitation, all of the above. Animal movement would also be animal movement controls, not, let them move freely. And then vaccination is always a day one response tool, true or false?
Okay, we'll give everybody a couple more seconds. People are voting quicker now.
They know they're in the home stretch. This is it.
Yeah, they're like, we not need to vote.
They're ready for a break.
All right, I'm going to go ahead and end the poll and share the results.
All right, let's see how you guys did. Yes, $100 billion a year for animal ag industry. Nicely done. All of the above, beautifully done. In a free country, we can use animal movement controls, stamping out, and sanitation, aka biosecurity, to help us with all of that. And oh, you guys are my favorite. Correct, false. Vaccination is not a day one response tool. All right, guys, that concludes everything that I had for you this morning. Thank you for your time and attention and participation.